We've seen two things today. We have seen QGraphics View
and multithreading.
We've seen multithreading, and now we'll talk about a thing called ModelView. So graphics view, you could use that in all of the world, the widget world, the graphics view world, of course, itself, and in the Qt Quick world. In the Qt Quick world, the items themselves were really Qt Graphics View, so you needed to learn a bit about that to be able to get your own items in the Qt Quick. You could have set up where you had a main window and everything in the widget world, and then part of that was your Qt Graphics View. Multithreading, obviously something that works with all three worlds. You'll have your widget world where you're just setting up the user interface for doing some mathematical calculation of thread. In Qt Quick, you could somehow need to Qt Quick would just be the representation, and then underneath you would have the have multi-threaded data structures, whatever, to calculate things. The last thing here, however, is really just the widget world. Well, it's Qt Quick world to some extent.
Right. It's
Qt Quick world until we start talking about tree models, which is when it's getting really difficult because Qt Quick doesn't have a tree view. There are certain facilities in Qt Quick to actually have a tree model in C++ that you in Qt Quick like navigate your way through, click on an item, and you get into a sub-item of that. But that's not really a usual use case there.
Yeah.
Before we get started with ModelView, let me just tell you a short story from my own personal life, just to motivate this thing here. Back in 2001 or something like that, I started developing a hobby application of my own, a photo album application called Key Photo Album. My photo album application had obviously a thumbnail viewer, just like the one up there. This was 2002. Qt was in Qt 3.3, I think, way back then. So my thumbnail viewer was a very simple widget. It was, let me not confuse you with the naming of Qt 3 counterparts to Qt 4, so I'll just name them as if they were Qt 4. So it was a QList widget. QList widget is a widget thingy. You give it the data, so you create thumbnail items in that thing, and you'll create one for each of the thumbnails that I had. It worked great. And I had just got a digital camera, so I started taking pictures, and it was great to have all my images on my computer, so I started scanning my old photos so they got in there. And it didn't take long until my X server started crashing every time I brought up my application. The problem was that each of these thumbnails, however small they were, each of those, when you have enough of those, they are X resources. So my X server ran out of memory because I read in all of those small thumbnails as soon as I started my application. And when I had like 5,000 of these, obviously it crashed. So what did I need? I need an on-demand loading of these thumbnails. I needed to only load them into the view whenever there was a need for them to be displayed. So I went and looked at the QList widgets counterpart in Q3 days. Its API, and it had a virtual method that I could override. That virtual method was a method that would be called on the subclass of the QList widget whenever it needed a thumbnail for the given cell. So it would take like the position of the cell and would return a QPix map, or it was a paint method or something like that I needed to implement in my QList widget. Can somebody hear me? Can hear this? Hear your teacher from back at the university saying separation of presentation and domain logic, huh? I had all my stuff for how I got my thumbnails off my disk completely intermixed with my code for displaying the thumbnail view that can be scrolled and everything. That was what we had to go with in the Q3 days. Being a good boy, I of course did as much abstraction and separation and stuff that I could, but still my only point of entrance was that method saying paint that cell or give me the pix map for that cell. fortunately, Qt 4 came around. Qt 4 has this separation of GUI and business logic that is called ModelView, and that's what we're going to talk about now.
Yep.
We'll start out talking about the concept of ModelView. It's a bit more down the line of the discussion I already started here. Most important thing about ModelView is to create your own models. So, and we'll see a bit down the road, models all of the time, delegate sometimes, view seldomly. The hard part of ModelView is not one-dimensional, it's not two-dimensional, it's the tree, not as in 1, 2, 3, but tree as in those that grows in your garden. That three-dimensional models, they are a bitch.
Yep.
And we'll spend quite a bit of that. Then we'll talk a bit about some value-based models. We don't talk about that before way down the material because we don't want you to start thinking of the value-based, but they are a good stopgap when you don't want to go all the way but still want some nice things in there. Proxy models. I know Volker loves proxy models, so he'll spend until 10 o'clock tonight talking about proxy models when we get there. And finally, as I said, models all the time, delegate sometimes, view seldomly. So at the end, we'll end talking about item views. We'll talk about delegates. And we will say one sentence about selection. There is a class in Qt called QSelectionModel, which just for the fun of it is not a model in the QAbstract item model kind of sense. So we'll tell you about that just at the end.
Okay, so we have mentioned the generic ModelViewcontroller concept as design pattern before. The way this is actually used in Qt is maybe slightly different from those terms. The view, that's the same. That's the thing that actually renders your data onto the screen. The way this rendering is done and the visual representation is defined, that's a component that's called delegate in Qt. A delegate renders a single cell of your data, and it also defines how you can interact with that data. If you, for example, have something is editable, then depending on the type, that will show you different widgets. So that's where you control that. And then, of course, the core part is the model. But the key difference here is that the model does not hold your data. The model in the Qt sense is just an interface to your already existing internal data structures. It's a generic interface so that the built-in views in Qt can understand your data. So a common mistake is that you actually copy your data again when you write your model. But the idea is actually that you access the already existing structures from within the model and just implement that as an interface.
Returning to my photo album application, just enjoy how beautiful this is now. I have the view. That's the QList view these days. There's not a single line of code that is modifying the view. I have my model. That thing reads in my database, knowing about where my images is and what they belong to, and so on. And then I have a delegate that is painting each of the cells. So I have special requirements because I have all these annoying users that is like, could you also, okay, final feature I'll add. So you can have the label of the images underneath in the cell. You can have some tags underneath the cell, and all that stuff is a delegate that I implement. So model is an interface to the data that I have in an XML database on the disk. My delegate is painting individual cells and aligning them and stuff like that. And finally, I just use the view. I take it down the shelf, a QList view in the setup of icon mode, and off I go.
Yeah, the view containing stuff like layouting the individual cells and interaction behavior like drag and drop and selection, that's obviously the same most of the time, so you don't even need to touch that. Visual representation, that's the task of the delegate. If you want to customize that, you don't need to touch the view. It's enough if you adapt the delegate. And the model you nearly always need to write yourself, because there is no generic way Qt could know how your internal data structures look like. So you always have to provide the adapter to that, which is the model.
Click on some of link. Click on.
Oh, OK.
So just for a start here, those who've not done ModelView before, let's just show you how simple this stuff can be. We have a model here that is representing the data. Somebody's trying to. I can shout louder. Trust me. Hello. OK, we have a model here representing the data, the file system on Volker's computer. So Volker is starting to get slightly worried here because we're going to.
No.
Anyway, we can see that we actually have two views on the same model. On the left side, you will see a tree view. On the right side, we will see a list view in just one of the directories there. And let's see the code for this. That's
OK.
You have a black screen?
Yeah, that's a bug in this presenting application we're using. I have no idea who wrote that.
OK, this is definitely not something I wrote. Qt Creator is not my baby. There we are.
Seems to be some repaint problem.
Did you try turning it off and on again? So here we have here is the complete application for this model view. We have a splitter that makes sure that they are split next to each other. We have a tree model, or tree view, sorry, and a list view. We have a Q file system model. That is the one and only model that you'll get for free. All the other models you'll have to implement yourself. But Nokia thought, hey, we'll create a model just for Jesper to demonstrate in these classes that is representing the data structure on your hard disk. So we have this Q file system model. And I say tree set model, list set model, and there we are.
Right. So do you want to have the other example as well? So
no, it's OK.
Slightly different visual representation. The Mac-like column view, so where you navigate down the tree in 3 different columns.
Well, in different columns, actually.
Yeah.
Well, so this is
same model,
another view, same model, just a different kind of view put on the data. We are back, non-black. Yeah. OK. Not back. What is going on here?
I have no idea.
Did you try turning it off and on again? Could you try turning it off and on again?
Yeah, I do that. There we go.
OK. This is the complete list of models available, at least when I read through the documentation recently. At the very most top, we have Q abstract item model. This is by far the hardest one to implement. And often, you don't need to do that. If you just want a simple list of things, and there's lots of simple list of things out there. A list of the names of all the people in this room. We don't need a tree for that. Or a list of all the cities in the world. We don't need a tree for that. We could get a tree if we had like country and then city. Right. But if just a list of cities, we don't need a list for that, or a tree for that. In that case, subclass Q abstract list model, it is pretty trivial to implement. That's pretty easy. If you want two-dimensional, so something that you represent in a table, Q abstract table model, almost as simple. One more virtual method to implement, namely the one telling you how many columns there is. From there on, there is a few others. There is the Q standard item model, and notice how that name do not include the word abstract. That is a data model where you give the data to it, forget all about that until we've seen all of ModelView. Q file system model, we saw that already. That's the one representing Volker's hard disk. And finally, we have 2 proxy models.
Okay. Yeah, there's QAbstract proxy model, the base class. A proxy model is a model that takes another model as input or as data and implements some kind of transformation on top of it. So very, very powerful tool to isolate various concerns of your data processing. And yeah, we have QAbstract proxy model, which is the generic version, and we have one implementation that you can actually use out of the box, and that is sort filter proxy model, which implements sorting and filtering, or any combination thereof. So if we would want to have sorting in the file system view, we just put a sorting model on top of the file system model, and it will take care of that. Or if we want to filter out all files of a specific user or something like that, we can just apply a filter on top of that. We don't need to bother with all these features in our actual model implementation, but we can add those on top of it.
See, I told you, he's just insanely in love with proxy models. Any chance he gets, he's continuing talking about it forever. We will, fortunately, get back to talk much more about proxy models. All you need to know really now is that a proxy model is also a model. It has a certain ways with things, so it looks both like a model and like a view kind of thing, but it is one of those models that we'll be looking at. Let's try something fun here. Volker, get over there.
Okay.
Camera, just follow Volker. Okay, let me show you how incredible cool I am. I can replicate that tree over there. I cannot see the tree, but now you can't see that I'm replicating either. You can't see the camera. I can replicate that tree by just asking Volker a few questions. Volker, how many top-level items do you have?
1.
Really? I guess.
Well, that's how you paint it.
Okay, he has 1. Volker, what is the text of the topmost row in your top level?
A.
Okay, Volker, how many rows do you have underneath A?
3.
Making a note here. 3. Okay, Volker, underneath A, what is the text of the first row?
B.
Awesome. Volker, underneath A, you have a B. What is the, how many rows do you have there?
None.
Okay, underneath A, what is the text of the second row?
C.
Awesome. Volker, underneath A, you had that C. How many rows do you have underneath that one?
1.
Carry on. Underneath, and we have an E further down. Volker, underneath, well, actually on the B, right? Underneath A, you had a B, under which you had an E. How many children do you have there?
1.
Okay. Underneath A, under which there is an E. What is the first row?
F.
And I guess you're getting the drift here. I will continue enumerating the whole path down here to the given item that I'm asking Volker about. It would be nice if Volker was just a bit stateful so that he would know where I was. So like, Volker, we are talking about that F. Tell me the first row.
G.
Tell me the next row.
H.
No, that's underneath, you silly thing. Can I get a new assistant? See, if Volker was a bit stateful, so he knew what I was talking about, that would be great, because let's try this again. This time, Volker, underneath A, you had a B, under which you had an E, which you had an F, and underneath that you had a G. What was the color of that?
Black.
Okay, underneath what is the font of that? Do you have a pix map of that? And all the time, I'm asking a load of questions. And that thing that makes it much easier for us to talk about. I would like just a pointer into Volker's data structure. Of course, I cannot get a pointer into Volker's data structure. Volker, he learned about pointers when I was writing books about Qt I learned this morning, so he knows about pointers, obviously. And he's not giving them out. What he will give me out instead is this fancy thing. It's an abstraction. It's called a QModel index. QModel index will go like this. Volker, can you give me a QModel index for your F? And I'll have a QModel index for the F. And I'll say, Volker, with this model index for F, can you please tell me what is the color? For this model index of F, can you tell me what's the font? For this model index of F, can you tell me what is the tooltip? What's this hint? All the things that I want to know about it. We'll get back to QModel index a bit later.
Okay.
This is just the slight teaser, because when we start talking about model view in the tree view world, it's going to be really annoying. We will see model indexes in the API a bit earlier on, or a bit later on here, before we get to the tree models.
Yep.
And these model indexes, they will be in your face all the time. You will go and fetch a bit of information out of these model indexes, but they will really only be real trouble once we start to get to the tree models.
Right.
There is a special model index type. Let's skip that. There is a persistent model index. Somebody remind me once we're through with the tree model to tell what a model index is. So anyway, a model index, just a reference into a pointer into a data structure. It consists of, you can think of it conceptually as containing three informations: row, column, and parent model index. So that's just like a pointer structure. So I have this one here. It is, this one here, it's row 1, 0, 1. Row 1, it's column 0, and the parent is this one. So that's model index is thought of from the outside. There is a model index from the inside, which looks slightly different. We'll get back to that.
I think that's what you was just
Here's a
showing us. We have these three components in a model index as far as the outside is concerned. Row and column index, and the parent index. The parent index for the simple 2D, 1D, and 2D case we can ignore for now. So all we basically get in a list or table scenario is a row and a column index. And that's easy enough to work with for now, right? Index starts at 0 and only affects the current hierarchy.
And this, if you're sitting there slightly confused, saying, what are they talking about? What we're trying to show you now is what the model looks like from the outside. The code that we're showing you, you're never going to write that. You're not going to write a code like what we see up there, model pointer index 2, 1. Who is going to write that code?
The view.
The view. So we're telling you, we just hooked ourselves into the pipeline, the communication between the view that knows how to ask for the real data underneath. It knows how to do that through an interface that the model is offering. And we're trying to tell you how is that going on, because once we are trying to implement that interface, it's nice to know what's going on.
Right. Fortunately,
if you ever need to, the QModel index parenthesis open parenthesis close in that is actually defaulted like that. So the QModel index parenthesis open parenthesis close indicates the null index, and the null index is usually thought of as sitting here on top. So here is
right. It's the sort of the virtual parent item for your top level entries in the model.
Yep. And that's what this indication, this painting that you see on the screenshot here indicate, that you have this model index on the top. You don't really think of that. You just think of that you can ask for an index for a given row, column in your table. The model index, that's just something that comes with the territory, because that you need to implement a virtual or an abstract base class that are powerful enough to even handle trees.
Right.
Had I worked with Trolltech many years ago, And I'm sure that you'll find trolls or Nokians around these days which will agree with me. It might have been a bit of an over abstractification, is that even a word, of making it possible to have the same kind of class fit into all the different kind of views. When you are to implement something as simple that can generate data to a one-dimensional view, you implement and you see in the API something that's rather complex because it also works with the tree view. We'll see that in a few slides.
Yep.
Here's the tree.
Okay, so yeah, now we see how to obtain the model indices for the tree scenario, and that's exactly what we just did here when navigating through the tree. So you ask for the index on the top level in this example A, which is the 0, 0 cell on the top level table, and then you ask for an index below that. So you use the index of cell A as a parent for cell B, which is one hierarchy level down, second row, first column, so 1, 0 as the index. And as mentioned earlier, the row count and the column count is always based on the same hierarchy level. So cell C here is in the third row on top level, so row index 2, not on the fifth row overall, because otherwise we would need to count the rows in the entire hierarchy above us, which is basically recursive walking through the tree, and that's way too expensive. So we only look at one hierarchy level when using the row and column counts. Yeah, apart from that, it's same as we just saw for the table.
I want to know lots of things. I was asking him for the text, the color, the font, and all those things. And the view obviously needs to know about all these things. And the way that the view does that, well, actually, we haven't seen so far. I'll just give you a hint here. The QAbstract item model has a method called data. The data method takes two parameters. It takes a model index. So I'm talking about this one. That's the model index. And it takes an enum, which tells what am I actually asking for. Am I asking for the text? Am I asking for the color? Am I asking for whatever? And these are enums. They are called item roles, and we have a bunch of these. We have a display role, which is the text. We have an edit role, which is the text when I'm editing it. So it could have, in the tree here, it could say Mr. Pedersen, and when you click on that, it would change into being Jesper Pedersen for editing, and then when done, there would be code that knew that, in the model obviously, that knew to return me as Mr. Pedersen instead of whatever the full name is.
The edit role is even more important if you have data types that are not strings. So display role is always a string for display purposes. So if you have a number that's converted into a string in whatever local aware formatting you might want to use, while edit role is the actual data type. So something you can plug into a widget that can actually edit this. So in case of a number, you would maybe use a spin box, and there, of course, you need an integer to put it in there, and that's what you get from edit role.
And we even have a list here of all the roles: display role, decoration role, edit role, tooltip role, status tip role. So that's when the view wants to show a tooltip, status tip, or what's this. There is a font role, text alignment role, and so on. And again, those few of you that was around in Qt 3 days appreciate this. I wrote this book, as Volker was telling previously. What was it called? Practical Qt. Like 50 tiny chapters on regular problems that you had in the Qt 3 days. And I think there was like at least 10 chapters in that book on how to get around what would, in Qt 4 lingo, be the QList widget. How you just could change the font in a given cell. Fortunately, Trolltake read that book and fixed all those bugs, so now it's useless.
Yep.
Thank you, Trolltake.
And yeah, again, like we saw in graphics view earlier, we have an interface here, or an API here, that is very, very generic. So you get some enum value and we return a Q-variant. Again, that makes it very powerful and allows you to extend it with your own custom roles to deliver your own internal data types or your extra information for that cell that you might need in your own delegate or in a proxy model or whatever you do with the model on top of it.
An example of this that makes it perhaps a little less abstract is that if you have a view, this stuff here works in Qt Quick. So in Qt Quick, you have a list view. Each of the cells are painted with a delegate, and the delegate is just a Qt Quick element. And in there, you will say, so the text is, and then a property name, which maps to something that we'll pick out of the model. And in those situations, all the examples I've seen, you don't go and ask the model for the display role and all these things, the font and display and all that stuff you have set up in Qt Quick yourself by regular Qt Quick mechanism. But what you instead do is to ask for the real data. So in terms of give me the first name, give me the second name, and then you can have that model in different view. One would be showing Mr. Pedersen, the other would show Jesper Pedersen. Right. And they would just go and fetch the information from the model there.
And since you in Qt Quick can't use more than one column, this is the usual workaround there to actually provide more than one information per row in your model. But in a table in the widget world, you can just have one column for the first name, one column for the last name. That won't work in Qt Quick.
So that was the ModelView basic. Just a super fast recap. Data all beneath down there. Your data comes out of a database. Let that be SQL, let that be XML, let that be a guy sitting in India typing things in that comes in over a TCP connection. I don't care how your data comes in. Those data come in somehow into your application. You know how they come in. They are different in each and every single application. All the way on the top, we have 3 different views. We have a list view, we have a table view, we have a tree view that are capable of showing what is underneath.
Well, actually, we also have the column view and the combo box and whatever you have in QML.
You're not letting me off the hook, are you?
Yeah.
We have more views, but these are the 3 main views. He is indeed right. We have the column view, and a combo box can even use the stuff there. We have the Volker shut up view that is capable of talking ModelView too. We have a bunch of view up there, data down there, and in between we have a class that will convert that data from down there to that view up there. It speaks a language that this view up there talks, and it speaks a language of the data down there, and it wraps it up. That is the class that we'll be looking at much more now.
Yep.
Q abstract item model, or actually we'll start looking at one of its subclasses, the Q list,
right.
Abstract list model.
If you want to implement the translation between your own data structures and the language the view speaks, we need to implement some subclass of abstract item model. There are 3. We mentioned that as well already. The list model, the table model, and the very generic one, which is also the one you use for trees. There are 2 other ones, string list model and standard item model, which are different in the sense that you copy the data into those instead of them being adapters on your actual data. So we'll not look at those for now, but we'll start with the abstract list model. So the easiest case, just one-dimensional list, single column, multiple rows. In that case, it's enough to inherit from abstract list model. And that has 2 pure virtual methods. So virtual methods we have to override in any case. And that's row count, which returns a simple integer and tells us how many rows we have in that list. And data, that's the one we were talking about earlier together with the roles. That's what actually returns what's in those individual rows.
Just for the fun of it here, those that already knows ModelView pretty well, don't answer. Give me your best shot, those that this is completely new to. What is the parameters to row count? It takes one parameter, not zero, one parameter. Come again? A Q model index. That is a weird thing. Volker is telling us here that we have this one-dimensional thing, and I can tell how many rows there is in my one-dimensional list, and I'll take a Q model index as parameter. And you are entirely right. And why does it do that? Because that it's implementing a more abstract interface from above, the Q abstract item model. That one has row count. And when I'm down here, I'm asking Volker, what is underneath? How many rows do you have underneath E? Then, of course, he needs to know which of those I'm in. That's one of the confusing things when you start out with ModelView in the symbols.
Yes, absolutely.
Just ignore that model index.
Right. I think it even defaults to the parent model index, right? So
sure, but it's a virtual method, so you better specify that parameter. Otherwise,
well, nowadays people use this IDE stuff, which auto-completes this.
Cat? Cat? That's not the editor?
No, no. So this is not such a big problem nowadays anymore.
Fair enough.
Yeah, so those two methods we have to implement in any case, data and row count. But apart from those, there's a number of additional methods we can override. There's something called header data. So that's for the row and column headers that we can display in the views. And if we want to have like Excel-like row numbers and letters at the columns, then we can return that in header data.
Did you just say Excel-like?
Excel-like, yeah. You know.
That's like a spreadsheet, right? That's my domain.
Yeah, that's your domain. So I'm trying to make it relate to you.
Fair enough.
What else do we have? Flex. That allows us, similar to what we saw in graphics view, to enable certain built-in interactions on individual cells in a model. That includes stuff like drag and drop, selection, any kind. Yeah, you can disable interaction altogether, and it's just grayed out, and you can't even click on it. You can enable editing, which is off by default. So there's a number of built-in interactions that you can enable there. And if you enable editing, then you also should implement set data, which is the counterpart to data. Similar API, you also get the. Do you actually get the role? No, you get always edit role, right? I
thought there was auto-completion in your editor, not in your brain, huh?
Nah, I rely too much on the editor. But you get the variant with whatever the user changed there, and then you, of course, need to update your internal data structures to that new value. What else do we have? Yeah, insert and remove rows. So if you want to give the user the ability to add new rows or delete rows, then we have an interface for that as well. But all of this is optional. The very least you need is row count and data to actually see read-only data on the screen. Okay.
That was the list model. I'll make it slightly more complicated. We'll talk about the table model. So if you just not have one-dimensional list, but like a table, all of the above applies, and you will just implement column count, now telling how many columns are there. And just as we had insert rows, we have insert columns, and just like we had insert or remove rows, we have remove columns. But apart from that, it's the same thing. And you forgot to show the example here.
Oh, yeah, okay.
Your keyboard.
All right, consists of three different.
So what we're looking at now is a very simple list model. It is displaying in 3 different views. There is the Then there is the first one, which is a list view, just a regular for one-dimensional. The second one that he's pointing at now is a tree view. Not very interesting to see a list in a tree, because there's not going to be anything underneath. But hey, why wouldn't we? And the final one is the table view. And this one is even editable. So if you... that's the wrong way around. You're supposed to edit Sweden and make that Norway too.
Oh, okay.
You know, Norway is really rich on oil, and Sweden, the question is, how will you make Sweden much more rich? They should just attack Norway, and when Norway start defending themselves, say, okay, we give up, you can have us. It's okay to laugh. I love that joke. Nobody understands it.
Yeah, but what you see there is all the views update whenever I change one of those. So they all point to the same model, and we see the same again as we saw in graphics view. We can have multiple views, even different views, pointing to the same model. And whenever I change the model, all the views will automatically update and show the same content.
Why would you ever want to do that?
Well, exactly the same data, probably not, but you can combine that with proxy models and only show a subset in one view and show a subset in another view. But we are getting to that. OK, you want to see the code for that?
I want to see the code, just for the fun of it.
OK, let me get rid of all of this.
Too many files open.
Yeah, there we go.
So here's our very simple, it's a string list model. And those of you who haven't gone to sleep yet would say, hey, wait a minute, isn't there a Q string list model? Indeed, there is. This is more or less the implementation. I wrote this in the training material back before Qt 4 was released, and Nokia obviously reviewed it and said, hey, that's a good idea. We will add that to Qt. So sorry that you're going to see what's in Qt. String list model is a subclass of Q abstract list model. So it needs to implement at least two methods, row count and data. And by the way, the string list model takes a list of strings as a parameter, remembers that in an instance variable, and now we're just referring to that data in that instance variable. Row count, it is just returning the amount of items I have in my list. That's what we have there. There is a if parent is valid, return 0. Why is that?
Well, it's like we mentioned earlier, row count is so generic that it can also handle trees. And in the case of a tree, we would get a valid parent index because the top level one is the invalid one. So if we are looking at children of a top level item, we would get the model index of this one as a parent. So that would be valid. And of course, we don't have any children, so we have this safety check there. To actually be a real list and only have top-level items in there.
So had this not been there, and I had clicked on Denmark in my tree, I would see there was Denmark and all them underneath, and click on Denmark, I'll see and see and see. Try this at home, and you'll see that I'm full of... the QList model has a parallel interface somewhere where it tells the view, no, I'm one-dimensional, don't try this. But hey, this could have been another view, the Volker get off my back view that we talked about previously, that was communicating with this model. And the view could be giving the model crappy data. It's not that likely that there's going to be an implementation called Volker get off my back view. There is, however, a very good chance that there will be, Jesper, see, I created a proxy model from Volker because he loves proxy model. And remember, proxy models, they act as views towards the model underneath. So you'll see out throughout the whole code that we are doing this in a better safe than sorry way. When the application is crashing, better have it crash on an assert that I was trying to do something beyond the data structure than just crashing from me doing something. Because I am an interface towards something that could ask me stupid questions from above.
Right. And since this stuff is very painful to debug with all the model index stuff and complex cascades of method calls, it's a common pattern that you have in models that they are full of asserts and safety checks just to be save there and not even get into any of these problems.
The next method is the data method. That is 15 minutes. The data method is where we will be returning the data from our model to the view. It takes, as you can see, a QModel index. Which row am I talking about, or which cell am I talking about, and the role. And first of all, it checks whether the index is valid. If it's the invalid one, then for some reason the view said, what is the text above the tree? Like, what? Return qvariant. Then I check whether whether the row that it's asking about is valid. Again, the view could have been a broken one. If it's invalid, I'll just say return qvariant.
Well, the more common case that you get invalid questions there is that you wrongly implemented one of the other methods. So if you return a wrong row count, you, of course, might get a wrong model index here and then crash when accessing that. In this very simple case where we only have a static string list, that's very unlikely to happen. But we'll see later, once your data structures actually start to change, that is actually a very real possibility that there's some inconsistencies between your actual data structures and what your model thinks the status of that structures is.
The next thing is a very common problem among people new to this thingy here. Volker, can you stand over here? I'm talking about this one here now.
Yep.
Can you point finger to that one, to the D? Can you just, whenever I ask something, just say D?
Yeah.
Here's a model index, Volker. What is the text?
D.
Awesome. Here's a model index, Volker. What is the, what's this?
D.
Okay. Here's a model index, Volker. What is the font?
D.
Here is a model index, Volker. Is this a checkable list item?
D.
See, and you'll see, and we'll implement this. I'm sure we'll implement a bit of code with ModelView in just a second, and you will suddenly see all of your items as checkboxes. Because that's one of the things that the view can ask the model: are the items checkable? And if Volker forgot the check of is it asking for the display row and not for the whether it's a checkable or whether it's the font or whatever, if you forget that check, you will answer D or whatever data you have there. And, well, it's a qvariant returned. And the qvariant is this nice class that will not crash on you if you put in a string and try to pull out a bool. So we'll just say, sure, I guess that means true.
Right. And, yeah, it's the checkbox is a very good indicator that you have that problem. But weirdly aligned cells, strange cell sizes, strange column headers or strange column rows, that's all pointing to the same problem. So you're checking for the wrong rows or not checking for the rows at all.
And finally, in our simple example, we get to what it's really about, returning the data. We have this string list, and we just go for what is at a given index. We know we're asking for the text. We know we're in the right range. We know that the model index is valid, so now we can return. In all other cases, just return qvariant and say whatever. And that is just perfectly OK.
Right. You don't have to handle all the roles. If you don't know what to do with that role, or if you want just the default behavior, returning the invalid qvariant will cause exactly that. So you don't need to return the default font for font role if you want the default font. That will happen automatically.
Yeah. This is all that is needed if all you want to do is to return or to implement something that can be showed in a list, how many items are there, and then just returning the items. But we saw that Volker was so mean that he put this into a table, and to just look good in the table, we had a text at the top, and that is what the header data section is about. And notice the parameter here, int section, so that is a line 1, 0, 1, 2, 3, or 0, 1, 2, whatever. Is it the horizontal or the vertical? And here comes the cool one, the role again. So actually, if I want a header with blue background and a checkbox and whatnot, I can not just return the text here. I could also return the font color and the what's this and all these things.
Items.
That's Nice API.
Yep. And just like with the role, a common mistake there is to not check for the orientation. And in a list view or a tree view, you might not even notice, but once you put it in a table view, you suddenly see all your column headers also in the first couple of rows, and then it starts to continue with row numbers, which means you just forget the check for horizontal there.
This is a editable model that we're implementing, so you could see that Volker could even change the countries. And for the view to be able to know that it should allow that you click on a cell and edit it, the view will ask the model, can you please give me the flags for this one, for this particular model index? So it's per index. So I could have one cell that is editable, another one that's not editable. So it'll ask for the flags. And again, if this is an invalid one, better safe than sorry, just return the flags of the superclass. Otherwise, I will return the flags and bitwise OR it with item is editable. And now the user can click on it, he can change it, and when he does that, the setData method will be called, which looks like this.
Right, so again, safety checks for invalid index. We actually get the role as an argument. So usually that's the edit role, which is what the edit delegate will return you. And in the variant value argument, you get the new value that the user has set. So you can update your internal data structures to contain that new value. You could implement additional safety checks there if the value is in an allowed range or of the right type or whatever. That's why it has a bool return value to indicate to the view that the edit was successful or was rejected. And then there's one important thing here. We need to inform all the other views looking at this model that the data actually has changed. Like if you remember, when I was editing a single cell, all the other views were updating as well. And that's why we have the emit data change there, which we give a range of model indices that, for the range that has changed. In this case, it's just a single cell, so we can just use the same index twice.
So things are getting slightly more difficult here. I promised you it's only 2 virtual methods, but well, the API consists of a number of methods, but also a number of signals. You could think of the signals as being part of the API. And you need to follow the rules outlined by the great ModelView gods, saying that when your data change, you should emit the data change signal, specifying a range in your layout of where the data changed. And that is actually one of the harder part of ModelView.
Right.
He'll say proxy model now, bet you.
Yeah, that's especially funny in proxy models to react to the changes in the source model. But we'll see later there's a whole bunch of signals, not just data changed, to inform views or proxy models about changes in the internal data structures. Data change is the easiest one when just the content of a single cell changed. But you could change the hierarchy, you could reorder stuff. So really complex changes, and then we have a bunch of extra signals. And I think we will see a few more when we look at insert rows. I didn't even demo that. I didn't know the application even can do that. So
you can't from the user interface.
Okay.
That's the trick.
So if you want to add extra countries to our example, we have to re-implement insert rows to inform the model that the user wanted to add an extra row. That's like insert rows in Excel. We'll get, again, the index of the parent where we actually want to add the rows to. In our case, that can only be the invalid one, so we have the usual safety check there. And then we see these begin insert rows and insert rows methods here. That's also part of the API for change notifications in the model. With data changed, we just emitted a signal directly because it's a so simple change, just content of the cell. For anything that changes the structure, you have signals, but they are only used by the view. You don't emit them directly. We have methods like these: begin, do something, end, do something. And they will take care of emitting the right signals. And you put them around the actual code that does the change on the internal structure. And within this block, the view will not ask the model for any updates, so you won't be caught in the middle of updating your internal structures, which then might result in inconsistent results. So you have to wrap your complex changes in this begin end.
And with the risk of confusing you, that's okay. We have a break soon, so you can come and bother me with, what did you just say in the break? That's fair enough. We have two kind of model indexes. We have QModel index, and we have that special one we just jumped over called QPersistent model index. And the QPersistent model index is a model index that will survive even changes to your model where rows are inserted. What's the difference? Well, QModel index is it's like catching a fart with your hands. Did I say that on video? It is something that will be gone right away. While the persistent model index, you can ask the model, give me a persistent model index. I am pointing at that one. Whatever you do, like insert something up here, my model index should still work. And the way that it can still work, and that's a good indication that you forgot something in your insert rows method. The way that it can still work is that the begin insert rows and end insert rows will make sure to update the persistent model indexes. When should you get a model index, and when should you get a persistent model index?
Well, model index is very, very temporary because it might contain raw pointers.
You don't dare saying fart, do you?
No. So they might become invalid with the next operation on the model, so you don't want to store them. If you have to store a model index for whatever reason, you need the persistent one. Very common example for that is the way how selections are implemented in the views. So if you have selected a couple of rows and the model changes, you want the selection to stay exactly there. You don't want to move it around or crash your view just because the model changed. So the view gets persistent model indexes on the range of rows that are selected. So this will automatically update whenever you change the model, add new rows or delete rows.
Yeah.
OK.
And finally, we have remove rows. Gee, that looks pretty
much the same.
Familiar. Begin remove rows, and end remove rows, and there you are. Do whatever you want.
Right. In the begin calls, you usually have to specify the area that you are about to insert or remove, so it knows where to look for the changes, and then end remove rows will emit the corresponding signals and will allow the view again to ask the model for updates. Yeah, I think that's it.
That's it. Back to the slides.
Back to the slides.
We have 1 minute and 40 seconds left.
And the slide is black again. Oh, no. Yeah, I think we talked about this a bit already, so let's complete that before the break. We saw data changed for, well, just content of a cell. We saw rows inserted, rows removed. There's counterparts for columns as well, for structural changes. The next bigger kind of change is changing the hierarchy. So if you start to reorder stuff here, like move this subtree up here, or or put all of those underneath the same parent. That's obviously more than just removing and adding columns, so you need to do more updates there. That's what layout changed is for. So that's what you use if there's still the same data, but the structure or the hierarchy changed. And then there's reset, which is for, everything I had before was invalid, start from scratch. So if you do reset, you will lose selection. You will basically lose anything that had persistent model indices, because any assumptions you had so far on the data is wrong. It means start completely from scratch.
So that's the emergency brake. When you can't get things working, you'll just start calling reset all over your code.
Right. That will well, you're always on the safe side with using reset. However, as I mentioned, you will lose selection and all kinds of previous state. And it's obviously slower because the view has to ask for more data. So use the one that is as small as possible. Use something that is as precise as possible, describes what you actually did change as far as your data structures provide that. And the more efficient the views will update, the more efficient the proxy models will update. And yeah, reset is kind of the emergency if you really do a complete reload and none of the previous assumptions hold anymore.
And time's up for a break. After the break, we will be talking about tree models. This is where you should get your brain smacked with a pan-galactic goggle blaster. It is really mind-boggling. We will tell you that to implement a tree model, you just need 2 new methods. And everybody will go, OK, I got that. And then we'll ask you how. And we'll spend half an hour trying to figure that out. We will talk about the other important thing, proxy models, and then a few other less cool things. But a break until 4:30.